Good, let's get started. So hello, wonderful. Good morning, good lunchtime, and good afternoon. Relative is respectively where you are. And let's just double check if anybody or if somebody sees the screen shared and whether this also works with the sound. We're currently using here Zoom for this webcast, using this the first time, and the challenge here is that I'm missing a few of my control elements. Good, video and audio is okay. Thank you so much. You are a dream. This sounds like a plan, so we can get started here. For this, that's like when you have a new platform, I apologize, then it's sometimes a little bit, where and how do I find out that this actually works? Good. So what do you want to do for the next half an hour, 45 minutes? Some of you might be still busy with some deadlines to get them done, maybe this week. So we want to talk and double check how advanced steel and actually Revit would work here together. And a little bit maybe to myself, I'm part of A2K for the last 9 years, looking a lot after the simulation visualization from the engineering side, and having been a structural engineer myself in the past. And so I'm gonna lead you now a little bit through advanced steel and Revit. Obviously also was as an engineer exposed to shop drawings and others. And yeah, well, I hope that I can lead you a little bit through the workflow. So we want to actually compare these two applications, advanced steel and Revit together. And we especially we would like to focus here a little bit on a round trip actually of the data. We want to see what comes in, what comes through, what is required, what are the pain points. Autodesk still has to improve. You know, software is just being programmed by humans. Humans are not perfect, so no, neither Autodesk is, neither I am. So, and there's still something we need to improve for this. Good. I have here somewhere our somewhere an advanced steel open, and if this now works with the new share, then I probably just do a different one. I just go here, share my whole screen. Come on, that's much easier. Otherwise, share this thing. Good. So we actually should see a beautiful, nice. We should actually see our. Come on. Should see my screen now with an advanced steel running in the back end. I'm using just similar common advanced steel 2020 here, and I have a few drawings, a few files for us prepared. So like any other AutoCAD, we can just open this up, and somewhere here there is a tiny file ready for us, and come DWG file. Also advanced steel is using, and then we can open this up. Very good. So advanced steel opens up. I find out my properties on the right hand side. Common AutoCAD interaction where we can pan, where we can actually also orbit, and it's a bit of a tiny plant support. I've used this for a few demos already, so maybe in 2-3 years, maybe the structure has been done. And then want to show you that we have here basically with advanced steel our common connections. We might use them on the top. There are no connections, though there's enough playground for us to add a few of those on, and so there's still where we can have a bit of a play. So when we select here our members, we see on the right hand side our properties. We're dealing here with beams. When we look into the profile of the beam, just pointing to right now here on the right hand side on the profile, under the section and profile, we see obviously must have something to do with an Australian PFC. We have, it's a 200 PFC, and if some of you are not familiar with advanced steel, then just select maybe one of your members, and you find, for instance, here our advanced steel properties. And it is indeed here, we have here these values accessible, like what we have just seen in the properties, and we could change this to any other section. Everything is available straight out of the box. Don't need to do anything for this, where we can adjust positioning, review naming, and work also with some custom attributes for this. These are then also being conveyed to our shop drawings if you wanted to. Additionally, when you, or in case if you have created your members within Advanced there, there's somewhere we find also our famous connection vault, and within the connection vaults we have all these steel connections ready. We can also do custom connections, where we can actually also do custom sections with Advanced there, and yeah, it's a nice alternative, cheap alternative to Tekla. Good. So when I want to get my advanced steel to talk with Revit, we find that we have here a tiny import and export tab with a lot of file formats we can work with. And here on the left hand side we find something with Revit. We find here our import, export, and also synchronize. So import, export, basically writing out a file, and synchronize would literally mean, well, I have an existing structure, actually want to update my structure. There's a tiny downside when using synchronize, that some tiny members, for instance, like bolts and others, they would actually not come through. But that's something what we can explore a little bit later. So having said this, we would need to do a little bit of a numbering of this, because otherwise the computer can't process our structure in any way. So you could start at all weird angles, finishing off your structure. You could start on the top, on the bottom, left and right. Well, the computer needs to figure out and work out which parts belong together. Hence, it's an extra task we need to do afterwards. So basically, getting the computer to play Cinderella, organize the structure, put the structure, the multi-parts, single parts into the right basket. And so this is what we now need to do. So we have here our numbering menu. And once we hit the OK, we see on the bottom that it took a few seconds, and then the computer did organize and did actually sort all the members. For that, good. Once we have done so, we can actually do anything and everything with this. One of this, what we want to do is with Revit, we can here export the structure. So we have, for instance, here exports the data to the SMLX file. Is a structural markup language file. That's what SMLX stands for. And we can here just export it. Have this here together. And for instance, I just call it 01 webcast. And then would save this. We have here on the right hand side, on the right button, then the export status. And so, well, we have now the whole steel structure. And by the way, if you want to bring this now in randomly into Revit 2019 or 20 others, as long as all steel connections are there, it actually would work. So we are not that picky on the year here. And you found, so here our Revit. When it comes now to the Revit, while it comes here now to the Revit, we know that we need to work with a template. And within this template, all the steel section, all these families need to reside, because otherwise we can't actually import it. With advanced steel, and the steel section is a bit different, because advanced steel here is having a platform, and obviously assumes that we want to deal with structural steel. So when we want to go, for instance, to any sections or others, and place, for instance, here any kind of member, we actually just would want to specify that we want to work with Australian section. That's it, and then we actually don't have to load them in. What we need to do with Revit is we need to find or make use of a clever template. I have a tiny template prepared for us. I don't want to rename it. And this template actually has all these sections already loaded, and then we can just start a nice new project. So if you want to double check this, if it has all the sections, and you need to have at least these sections you have used in your advanced steel. And on the left-hand side, we find our structure framing. And with the structure framings, we find here also these sections. So let me now double check a little bit the types. Here we have my type properties. We find that a little bit further to the bottom in our type parameter, that we have a couple of grayed out parameter, and based on this grayed out parameter, the import should actually find the section. Having said this, kind of maybe where Autodesk can improve is that it does not always find all sections. Why this is so, I don't know. If there's somebody in the Bay Area and throwing a dice, pressing on a button, that my Revit finds everything or not, I don't know. But sometimes it just does not find everything, and hence there's a mapping dialog popping up. But in general, we have a good chance that here and there's a section. I don't need to work through a whole mapping file now because I have this prepared, but to show you how this would work when we want to import it, we find under the add-in in Revit our advanced steel extensions, and here we can actually now import our SMLX file. We come from advanced steel import, so if we're using our advanced import, obviously while using Australia. And once we're here, we actually find here our webcast SMLX file. So open this up, computer rattles for a second. We have two aspects we need to map. First of all, these are the member sections. And that's beautiful. Just the UBs it didn't find. All the other members it actually did. And also the materials. So the material mapping works this way, that the materials we have in advanced steel shall be having the same name like we have this in Revit, for instance, and then we shouldn't have any issues. If you have any families, for instance, as an example here, we have a UB, a 310 UB, for instance, and we would like, for instance, to map this, then it's what kind of 40 something. Then we have another 200 UB, for instance. So it's actually not, actually it's fairly quick. Somewhere we find a 200 something, 22.3. Let's choose this one. For example, I would have any members missing. I can go just here to load my family actually on my dialog, and then actually would all work out. Okay, so we have a couple of other members here, and what I will do quickly is I might just open up my my other file, so I don't need to bother you with mapping my sections. And after you have mapped, for instance, your sections, then the steel structure actually opens up, and that actually comes in here in my Revit. And so obviously we see it's the same structure. And also one thing is, which we don't have to map, which come actually in automated, is you probably know that we have here under the structure our connections, and the same button actually also here under the steel tab. And a little bit further to the right hand side, we have a tiny arrow where we can specify our connection settings. All the connections we have here in this model, they are being transferred for us, so we don't need to map the connections. It's literally just a little bit of a family thing we need to address here. So these sections actually come in. If you want to use any additional section, then yeah, help yourself on the left hand side. That's a portfolio. This is our library we have. Just make use of those. Having said this, there's also tiny specialty with 2020 and 2019, where 2020 was improved, and we'll show you this in a second as well. when it comes to the connection. Good. So first, when we want to apply here any of these connections, I don't know if anybody ever has seen these. How this works, for instance, here now in Revit, in Advanced Studio, it works absolutely the same way. So it would be here a connection in Advanced Steel. It would be my my connection vault. I can select now, for instance, here 2 beams if I wanted to, and then maybe I need to jump back because of my contextual tab in Revit, and then I can actually apply a connection. By default, it creates a generic connection, and then through my type selector, I can actually here choose another connection. So choose, for instance, if I want to use a moment end plate, or if you want to have a gusset plate or others, you can just choose. The other way would be around if you, for instance, click on the connection, and then you need to actually do a multi-selection. Remember, it is with Control in Revit. Select, for instance, your 2 beams, and then press the Enter button. The Enter button reminds us a little bit on AutoCAD, yes, because this tool otherwise does not know if you're done with your selection. Computers are pretty bad in reading minds, and so hence we have for this the Enter button. Looking here into the symbol, we find that we can actually here also swap major beam or secondary beam, which would also allow us here in case to change here the the setup from our connections here. So we have here, for instance, another connections. We see blue means it's calculated here, and then we see that it created here a clade. Well, secondary beam obviously is connected to the first one, as mentioned here. Looks a little bit dodgy probably. We probably would assume that we have the PFC actually. So this means that we can actually now swap it, and then it probably looks a bit more feasible, what we would find maybe out there. Great. So what we next have is here that these connections are being driven by parameters. These are similar parameters as we would find this also in Advanced Steel. I have good news, they're actually the same parameters. And going here to our edit type in our Revit 2020, we find those here, the modify parameter available under our edit. We are probably familiar having system families, as example, floors, slabs, walls, and others that we have here an edit parameter or edit sandwich or edit combination in our type properties. Same thing here as well, including a tiny preview popping up then on the left-hand side, which would allow us to design the connection here. The connections display in our fine detail. So view, so the detail view needs to be at fine. Also, when you go to your steel connections under the visible and graphic overrides, they then would display in the main window. Here in the edit connection type, they actually always display regardless. Wouldn't make sense otherwise, and would then allow me here to tweak and twink actually these this connection. It is not live here. When I would do it in Advanced Steel, the whole connection would be live. So whenever I change something in Advanced Steel, just a tiny bolt, it's immediately regenerated, and it would automatically update here my connection. Great. So having said this here, we find all kinds of variety of bolts and holes, whatever I'm up to. Probably if you wanted to know about any AS 1111 or 1252, we have those available as well. My size, so when I make this, for instance, let's say maybe a little bit smaller, we see it updates here, but not here on the left-hand side. It's just here my preview, which updates in Revit. And then we have different washer combinations, for instance, nuts, 2 washers, nuts and 3 washer if you wanted to. And so when we, for instance, change this just nuts and washer, you see that one of the washer here on the head is actually missing. And when we go here to nuts and 2 washers, it's actually there. Okay, so it's on a fine detail level. If you want to double check your stiffness and When we have maybe here plate layout, plate shape is default, plate layout, flange, good. So let's start here with the plate here first. Let me quickly maybe zoom out a little bit, just show you that you actually see this plate a little bit from this side here. Good. And so what types of plates, what type of plates you wanna use here? For instance, just have a regular one, you see just welded to our web here. And then we can actually also say, I actually want to connect it to the top, or I just want to have it maybe to the bottom relative to it, or we actually want to have it also both. So the detail here, these caters, these connections cater for all situations you might find on site. If you want to have a stiffener or not, there are some other options you can actually have a play with. There are too many now to run here through this webcast. I want to show you two other features we can add on, and then we want to bring in the structure back into advanced steel. So here we have another web stiffener. For instance, I just added on the other side because otherwise it would twist my fingernails. And so if you want to, for instance, turn this off, turn this on, we see that it actually does this live here, and so on and so on. Good, we're all happy with our connection, and now the M20s become now M16s, I think. We left this, and once we applied, we are actually here pretty happy, and we saw just that the bolts just became a bit smaller. For that. Great, so there is somewhere a tiny slide I have for 2019, and it's a PowerPoint slide. Let's double check if we have this one here. And I probably just started this. So when we go a little bit further down, there is a 2019 slide, which would allow me this in our instance parameter. So brilliant, that's the one. And now we need to make this a little bit larger here. Very good. So we see here that this is 2019. In the 2019, the combination, so the modify parameter, they actually were still instance parameter. This means so that you cannot save them. So in 2020, we can actually also here save them and save those then as a type, which would then allow me to to create literally a portfolio or add this actually onto my template, have, for instance, the most used 80% most used connections ready for me, and I don't need to run through any through all these combinations again. Advanced Steel does this as well. It offers us a library where we can actually save all these connections. Obviously, it's a bit advanced Steel, and then would allow me to save this and to save, of course, time for this. Other question is, you might probably have asked, where does it actually come in? Does actually the SMLX file respond to our survey point, project internal point, or project base point? And it actually interacts with the project base point here in this example. So I have here these 3 points just separated in one of the preparation sessions I had, and it corresponds here to the project base point. We need to double check probably that it is actually really the project base point. Let's go to our advanced steel and let's do a quick go to the top, and we see here actually our origin, which is, when you just remember the other screenshot I just have shown you, that it is actually the project base point for us. Good. So we have somewhere a Revit where we want to maybe add on another cleat somewhere around and about, and let's say maybe we want to add here a cleat on the top. Maybe let's say maybe here stiffener here on the top. We find here some options where we can also put here some cleats in. This is literally the same as it would be an in-place family. So if you're familiar with in-place families, structure connection, in-place families, you're probably very familiar with this. And we find here our contextual tab. We find that we also need to set at some stage a work plane that the computer can actually interpret the face we're pointing to, because our screen unfortunately is just 2D, and we could actually then add here a tiny, maybe tiny end plate, for instance, here on top of it. So fantastic. So if something didn't work that well, we can actually also adjust this here, make this stickers a little bit out, or line this in any way, maybe also a little bit up, as you probably would see here, would work as well. So a common interaction, like a common Revit sketch we actually have, and then apply it, and we have here our plate. So the material comes in here as instance parameter. So in case if you want to add another one in, let's say maybe you want to have maybe 250 something, and just adjust it, select it, and adjust it for this. Good. Maybe we want to prepare here a couple of bolts on the side, or a couple of other cleats. So we can also here, for instance, select here these two beams and actually then cope it as we see. So this was here for our coping tool we have here available. Also, if you now want to add maybe here another plate here on the find, again here, set for instance quickly your work plane, and then can add this on and apply it. Brilliant. So, and then have here a tiny end plate where probably we could now bolt these two actually here together here. Again here, unfortunately not yet that we can work with global parameters, not yet. So I need to still adjust here my my material if I wanted to. And somewhere we have here, for instance, a cleat, and then we have here a cleat, and sorry, we have a PFC and we have a cleat, and we want to maybe add on some bolts. Works also the other way. Then we can, for instance, have here bolts, and then give me the bolts. Good. And now we select these two, select the two members, and then select the face where you would like to apply these bolts. So even though these bolts are here now being driven by a rectangle or by a square, don't worry, because this just means we can use, for instance, here the half, that the both parameters would allow me to actually set actually also the edge distance nicely. So I'm going now from the overall area we want to actually bolt, we want to fix. I could have actually also taken the PFC, and now we actually see here these bolts coming in exactly on the edges. So if we now say, for instance, we want to have maybe a different standard here, as we see this is part of our instance parameter. We find, for instance, our 1252, 12 minute nuts, 2 washes. We have, you see this now updates nicely. We have here just maybe 2 bolts we want to have. We can work now here with the bottom parameters here. And say, for instance, we want to just have maybe one on side 1, or the other way around. You see that works as well here, in line or vertically. So the length, for instance, here the 203 we have, we could actually also say we just want to actually have this on our 150, and you see then we can actually bring them a little bit closer together. So here, to suit my PFC, we probably need to make them a little bit closer, and then we actually have here our nice connection actually together. Great. So when we now want to export here our structure from Revit to Advanced Steel, we don't need to calculate, or we don't need to organize and sort our structure. We can actually do this straight here, just going back to my add-ins, going to my export, and save it as an XMLX file. And then they could actually start refining it maybe in Advanced Steel. You can also bring the refined design them back into Revit or run the shop drawings. So we have here our export function. We can go to our advanced export and hit the OK. Save it as a file. Let's say, for instance, we have here our 4 webcast, which should do the trick. And we save it. Computer processes now our structure, and then we should have saved it. So going back now here to our advanced steer, we could now import it, but it would actually recreate the members in the same place. So I actually would have some double ups, what we don't want. Unless you have maybe a complete blank drawing, then of course you would import it, similar like we have done this in Revit. In our case now here, we probably want to consider a look into a tiny synchronize. And under the export and import function, we find here our synchronize. We load the webcast file in we have just created, and then open this up, hit the OK. It processes all my members. And we see here all the members. So some stuff was deleted. Okay, good, can happen. Some other stuff is new, that's good as well. And when we now, for instance, just want to process, please update all of them. Just click here on the status. Yes, okay, we accept it, please update it. And then please apply all these actions. So was here under the synchronize, just here load it and processes it for a second, and then take it, apply all actions. Okay, so next, when we see here on the bottom, what does it actually synchronize? And on the filter here, we see that it works through our beams, nodes, plates, columns, and others. We don't see here the bolts. That's why we have modeled before some bolts to show you that we still have here a bit of a room to improve. Also, there's a tiny issue happening with the plates, with my end plates, but stay tuned as a tiny finale. And then once we have here our status set, just apply all the actions, and then the computer should actually process this for us. So it might be now a bit busy. This would now allow us here to maybe to run through some of this, what we have seen and learned and heard about so far. And so remember, it was here our project base point, which was actually driving it. We have seen and learned that we have our connections within Revit already, that they don't need to be loaded, which is good. So it comes in automated. Next one is that when it comes here to the dialog, it's either you select first your beams, then switch back and have the the connection in Revit, or when you run the connection, then pick the connection button, and then you need to confirm your selection with an enter with a return. And we have first a generic connection here, which we then can change in 2020. We would have this available as a type parameter, where we can actually also store these. And that's just a bit of a matter of practicing warming up here the parameter we actually have available, and then it would, yeah, we can actually store them. Good. This we have seen already. We have here our then connections coming together, and fantastic. So here, as we remember in 2019, it wasn't. Then we had here the clade, where we need to specify our work plane, and then put, for instance, the end clade or end plate on it. All the common Revit features would apply as well, like we have seen before. And so it's of course now a bit of a question, how would this all work in advanced steel? Well, come on an advanced steel training course, then we can show it to you. Here we have also some other custom coping we can actually work with. And another one is what we haven't shown yet here is also as well that we can apply also some welds in Revit. Here, for instance, we can also, when we go with the bolts, we can actually also here have maybe also some slotted holes we can actually here build in case if the tolerance demands it on site. And I believe here is, for instance, my dialog we have for the welds. So that it also understands now welds here. Also these welds actually come through into advanced steel. So we see here a tiny weld symbol here on the side. And so you just would actually select your members, and then you would actually select the edge where you would like to have this weld. And then it would apply this weld here for us. Good, but I think it was good time for a bit of a tiny recap. Let's see what advanced steel actually did do now for us. And it is here on the bottom, still a little bit importing it, which should be done in a few seconds. Well, it has to compare a few members, but we should find this. It's just us probably a tiny bang, and then it's actually there. Good. Going back here to our screenshots, that we have here our features we can actually work with. Good. So next one is features we had up there. We discussed afterwards that we can make use here under the add-ins, where we have our advanced steel, button, where we can export our structure from Revit to advanced steel. Here, and just export it. And then afterwards, we have our common save dialog. We are probably familiar with. Also, this means that if you save it on the network, advanced steel could be maybe installed on another machine. We have our dialog where we then would need to update our sections. And this can sometimes take a coffee. But apart from this, it actually works quite well here. And then after we have here then updated, for instance here, our new members, just here hit the apply the actions, and then it would actually process actually our members. Okay, so I just mentioned before, when it doesn't find the material because the material has a different naming, we also have here a tiny mapping dialog coming up. And this can be, of course, eliminated if I tune my templates in Revit to have the same naming like my advanced steel has, for instance, 300 plus and others for my sections, and then it should actually work well for that. Good. So you see here then also that these connections would come in advanced steel. These are the connections we actually did design in Revit, including actually here our weld symbols and including actually our bolts. The other manual bolts that will not come in at this point. That's a little bit of an improvement. Welders can improve a little bit. And we also see a tiny issue here with the plate. So let's go back and double check if it's done already. It's still importing here. Or do we have somewhere dialog where it waits for us? This is where it is waiting for us. It's waiting on us. So with the 250, it's just via the webcast that I have missed. I haven't seen this, and hit the OK. So good. But at least I could show you some of the screenshots and a little bit recap, and then we actually see on the right hand side on the bottom that it actually just is a tiny bang, and then actually everything works. Good. Sometimes you need a coffee, or the coffee break was coarse because you missed a dialogue. This is the proof that we need a coffee sometimes. So having said this, we have now here our structure we were just working with before. And you probably saw me creating here the tiny stick connection in Revit here on the side. You see here with my bolts and everything else, and my bolts that actually came in nicely. We had here on the top some end plates. We saw here that this plates can sometimes come in a little bit on the different side. So within, it's just something you need to know, double check it, go to your advanced steel properties, and the positioning then needs to be corrected. And then it actually would make sense, because otherwise we would have some intersecting matter, which wouldn't work on site. And the other one is here. We have probably also seen here the coping, which actually came through, beautiful and nice. And then once we have here this cleat again, I just would need to double check actually my my positioning again, and then it would actually work well. We are missing a little bit these bolts here. These are the bolts I mentioned, the manual ones, which do not come in at here at this point. When I have the connection, they actually come in. The bolts are not being synchronized. If I would now import it, then actually the bolts actually come in. So if it is always better to synchronize, or if it is better to import, choose your weapon according to the workflow situation. What you want to do, what you want to achieve, what you're after. And so having this now here, I could now import it. We would see that it would double up the members. Hopefully I don't miss any dialog again. So we see those already coming in. So we see here that we have a few members on top of each other. We actually also see here our coping. We see also here the plate now doubling up. Are we done? Good. And somewhere we should have our bolts here. So we see here these bolts as being hidden by the other plate, but it's not a complicated thing, because the other plate we actually have the double up. We just delete, and here we just correct the justification, and then also the bolts are being updated. And we have here actually also the bolts which come actually in for that. Good. So what would be the next job? Of course, here with advanced steel, we have the options maybe to refine our connections, add some more connection, add different connections. We have the options to add a few special parts, work on my connections, work with some grading, have maybe some other options, like consider some other options like different stairs, different type of stairs, and others we can add on. Maybe design, redevelop, maybe some trusses. So there are a lot of options we actually then would have. Once we actually have done so, again, just to do the numbering, and then you could actually create and run actually your shop drawings, which is here after the numbering. Go here, you make use of individual drawings. If you want to have any cameras or others, if you want to detail them, or if you have just a simple drawing process. And after those, decide if you want to go after your assemblies, after your single parts and others. What you're after. For instance, here under the assemblies, say for instance, we want to have here an A1 template and have all my multi-parts or my selected multi-parts, and have those then being detailed. And then you see on the bottom that it actually creates the drawings now for me. I make use of the document manager to manage these. And will look after my generated drawings, management generated drawings, revision my generated drawings, preview my generated drawings. That's all what we can do with the document manager. It's a bit of a structure to play with, so hence, yeah, but if you would imagine if you wanted, if you would need to draw them all yourself and manage updates, it's much easier to generate them. Good for that. So what did we just see before here? We had a couple of things we would need to correct with our plights. And the other one we had to double check was here actually with our bolts. Not yet. We still want to see the shop drawings. Come on, go back. Very good, nice. So I just wanted to draw actually on it. And where's my pointers? I actually want to just draw on it with my pen, and then it jumped already one slide ahead as the computer wanted to go on a coffee break. So we have here our our bolts. Remember that they come in the manual bolts when we import it for that. Good. Here also symbols, my welding symbols come in also any type of coping, if it's a manual cope or if it's that you cope two members with each other, they both come in. And great. So somewhere we are done here now, hopefully. That looks good. And under the document manager, we actually see here all the details being generated for us. And if you want to open up a drawing, have a bit of a tiny nosy preview, we actually see here all these all the structures following our default common template for this. Great. So I hope this did help a little bit, stirred one or the other question up, and I hope that you enjoy it. And now I believe we can go with the computer lead to a tiny thank you for watching our webcast. And if you have any questions, just get back to us. If something doesn't work, get back to us. And we have a good support crew. We have a couple of chunk of people. We love to help you and support you also in advanced steel. And otherwise, have a wonderful, great Christmas. Have a relaxed time and enjoy the rest of your week. Thank you so much.